All right, people. Chapter 9. That means it's not a straight line. It's not in our slope-intercept form. So it's going to have a different look to it. So our standard form of a quadratic equation is y equals ax squared plus bx plus c. And when we talk about this, our parent function, that's the most basic value, the most basic graph that you're going to see is y equals x squared, where there's nothing else in front of it. There's nothing in front of the x squared. There's nothing after it. That's the most basic one. The graph of a quadratic function is called a parabola. Something we talk about here is that's the type of shape it looks like. We call it a parabola. So if we were to graph just a quick sketch here on the x-y axis, a parabola would look something like this. It's like a U-shaped type of graph with a curve there. It could also go the other way. In this case, it's the example here, it's opening upwards. It could also open downwards. And as you get further in math, they open sideways, left and right as well. And then the y-intercept is always the c value. C value is always the y-intercept. So when we look here, that's going to be your y-intercept. And we know what a y-intercept is. It's where it crosses the y-axis. So in our example that we just drew, our little sketch, this right here would be the y-intercept, which would be your c value. Okay? So a lot of terminology today and a lot of things we're going to talk about to analyze this stuff. And then tomorrow, or 9.1b, we'll really start getting to graphing it. All right? The next one, axis of symmetry. So this is a vertical line that intersects the parabola. Okay? And it kind of creates a mirror image with on each side. So again, if I just drew a little sketch, and this one I'll show you that it opens downward. Okay, we'll just have one that kind of opens downward here, like this. All right, in this little sketch, our axis of symmetry goes right down the middle. And so it kind of creates like a mirror on the right and the left. It's going to look exactly the same. And it contains the vertex, because here would be the vertex point. So it kind of contains that point here. All right, so that kind of contains that. That's the axis of symmetry. And then we can find the axis of symmetry. We can find that formula by this x equals negative b over 2a. So our x point of the vertex, your x value, would be negative b over 2a. That gives you the axis of symmetry. That's your line, right? Remember, x equals lines are straight vertical lines. So this line here, I know it's not the straightest, but that would be an x equals something line. It'd be a straight vertical line that goes through that x value. You can find that by negative b over 2a. And remember, how do you get these letters? Well, you're going to have your y equals ax squared plus bx plus c. So you're basically just taking that negative b value over 2 times the a value. Remember, your c value is always your y-intercept, but there is the idea. Okay, you just take those values from your equation, plug them in here, and you get your axis of symmetry. And we'll do some examples of that, and you'll be able to see a little bit easier. When we talk about the vertex, vertex is another term that we're going to talk about a lot about. This is the center of the graph. Okay, so it's the highest or lowest point of the parabola. Highest or lowest point of the parabola. So again, just a quick sketch here, and if I made my parabola like this, okay, Again, we got arrows going in each direction, so it extends on and on forever and ever. Your vertex point would be down there, okay? And we talked about it being the highest or lowest, depending on if the parabola opens up or down. The elastic parabola we drew, it opened downwards, so the vertex is at the top, right? This is actually an ordered pair, x, y. You could actually come up with a ordered pair here, x, y, at this point, okay? And finally, the last thing is to find the vertex, you're going to use the axis of symmetry and plug it in to the equation to find y. So I'm just going to move all this stuff up here just so you can see that a little better. Okay? So use the x value from the axis of symmetry and plug it into the equation to find y. Okay? So basically what you're doing is for your x value, remember your axis of symmetry was x equals negative b over 2a. So that's going to be your x coordinate, and then you're going to plug that in to find y. Whatever you get, plug in to find y. And I put that like this because this is basically your x coordinate, and this is your y coordinate over here. So I know it sounds weird, but once we do an example, you'll kind of see. Use that axis of symmetry, that's your x coordinate, then plug it into the equation, and then you'll spit out a y value for you. Okay? Let's keep rolling here. I know it's a lot. If you need to pause it, take all the stuff down, and get the information down, and be ready to roll. Okay, minimums and maximums. So what this is, we've got our equation, y equals ax squared plus bx plus c, and we're going to talk minimums and maximums. And in this case, a parabola opens upward when a is positive. Okay, so when a is positive, the parabola is going to open upwards. So a quick example of that would be like if we had, let's see here, just do a quick one, y equals 2x squared plus 5x plus 7. Well, in this case, you look at your a value, your a is positive, so we know that that's going to be a, it's going to open upward, okay? So if it opens upward, we'll just do a quick example there. If it opens upward, then in this case, your parabola would have a vertex point here would be a minimum because it's opening upward. Okay, so you have a minimum because your a value is positive. Okay, the opposite, and we'll do another one at that as well, but the lowest point here would be called your minimum. Okay, so your lowest point, your vertex actually here is the lowest point, and that would actually be called a minimum. The minimum value of that graph. Okay, parabola opens downward when a is negative. When a is negative. Okay, so an example, quick example would be, say, y equals negative x squared plus x minus 4. So let's just kind of take a look at one of those. Just a quick example. This is not exactly the graph, but if I just did a graph that did this, because a is negative, a value is negative, negative x in this case, or negative 1 in this case. Because of that, we're going to open downwards, which means you have a maximum value here at your vertex. Okay? That's what we call the highest point is a maximum value. Okay? And your minimum or maximum value is the y value of the vertex. So you just look at your y point and see. So in this case, your minimum value would be, let's see, just in this quick sketch here, we're up 1 here, your minimum value would be 1. And here your maximum value, 1, 2, 3, we'll say 4. Your maximum value would be 4 because you're going y. Remember, y goes up and down, so that's an easy way to discover those. Okay? So these graphs over here are not actually from these functions. I was just kind of giving you an idea of positives and negatives and stuff. Okay? Okay, so these are not actually the functions. Like I said, these are not actually the functions that go with these graphs. Just kind of giving you a quick examples. But again, if A is positive, it's going to open upward, so you're going to have a minimum value. And if it opens downward, it's going to be a negative A value, and we'll have a maximum there. Okay, and the Y value is your maximum or minimum stuff. All right, so let's move on. Okay, let's do some examples, and I think things will become a lot more clear for you if we do some examples here. All right, first. So the first thing we're going to do is find the vertex. All right. So in order to do that, what we have to do is first we have to find the axis of symmetry. So we're going to use that formula, x equals negative b over 2a. So we've got our example over here. And then we're going to use, for the ordered pair, I'm just going to put it in here, that we're going to use this for your x value, and then find y. There we go. And again, then we're going to find the y-intercept, which is always your c value. And we know that. It's always going to be your c value. If the c value is, if there is no c value, then your y-intercept is 0. It would cross at the origin then. Okay? And then we're going to find additional points if you need to, using an xy table. We remember the xy table. You can easily just go xy and find your values there if you need to, if you don't have at least 2 points from above. And then solve the equation by factoring. I'm just going to put if possible. If possible. Solve the equation by factoring. And remember, to do that, we have to set it equal to 0. That's how we solve. And I put if possible because if you can do it, if you factor it, then you'll actually get a couple more points, and you won't necessarily need to do an xy table because you'll have more points, if possible. But sometimes you can't factor it if it's prime, and then there's not much you can do. Okay, but that's kind of the steps you take. Again, find the vertex. You use the axis of symmetry to get your x value. Use that, plug it into the equation. Whatever you get here, plug it in here for your x's, and then you'll get a y value. Y-intercept is your c value. Use additional points if you have to graph, and then solve the equation by factoring. Okay, so let's do some examples, and we're not actually going to graph them today. We'll get on to graphing in the next section. All right, so here's our practice problem. We've got y equals x squared minus 2x minus 3. All right, so the first thing I'm going to do is I'm just going to say, get my a, b, and c's. You don't have to do this every time, but I just think it helps you out. A is 1, b is negative 2, and c is negative 3. It's just going to kind of help us in this situation. All right. So the first thing I want to do is find the axis of symmetry. So I've got to go with x equals negative b over 2a. X equals negative b over 2a. And so in order to do that, what I'm doing is I'm going to take the opposite of b. So it's going to be a positive 2. Does everyone see how I get a positive 2? My b value is negative 2, but it's a negative 2. So it would be a positive 2 here over 2 times a. So 2, and my a value was 1. So it's basically 2 times 2 over 2 times 1. So that's going to give us x equals 1, right? 2 over 2 is 1. So x is 1. So I know that inside for the first part of my vertex, my x value is 1. To find y, I basically take that 1, and I'm going to plug it in to my vertex. I'm going to take this to try and find my vertex. I'm actually going to plug it in to the equation here. I'm going to take this 1 and plug it in up here and here. Okay, so you're going to get a kind of like 1 squared minus 2 times 1 minus 3. Okay, and then we all know that 1 squared is 1. Minus 2 times 1 is going to be minus 2 minus 3. So I just kind of do those examples. 1 minus 2 minus 3 to get my y value. So 1 minus 2 we know is negative 1. Minus 3 more is negative 4. So my vertex here would be 1, negative 4. 1, negative 4. My y-intercept, remember that's always my c value. Here's my c value, negative 3. So my y-intercept is negative 3. And then factor, or let's go skip over here to maximum or minimum. Is it going to be, we're going to have a maximum value or a minimum value? Well, we look at our A. Our A value is positive. A value is positive, which means that it's going to open upward. A value is positive means it's opening upward. So our vertex would be down here, which would be a minimum value. And then the last thing would be to factor if possible. And so here's where I want you to pause it if you need to factor this. But if we plug in our equation here, x squared minus 2x minus 3, set it equal to 0. Remember, we want to solve, factor, and find solutions. So we're solving here. X squared minus 2x minus 3 equals 0. So the thing we want to do now is we want to factor it if possible. If it's possible, let's factor it. Okay? And in this case, we can factor it. Okay, so now if you need to pause it now, go ahead and pause it and do whatever you want to do. If you want to do the square method, or if you want to do the product sum table, it would be x squared. This would be negative 3 to get you started. Remember, we want to try to get our values here to add up to negative 2x. Okay, do the square method. Or maybe you want to do a product sum table here where you're multiplying to get a negative 3, because a times c would be negative 3. And you're adding to get a negative 2. Whatever you want to do. But I'm going to let you do that. Pause it to factor it if you need to, whatever step you mean, or if you get some check. But I'm going to kind of skip ahead here and say that when you factor this, you're going to get x minus 3, x plus 1 equals 0. And then we know how to solve these as well. We have x minus 3 equals 0, x plus 1 equals 0. And when we solve this, we just simply add 3 to both sides. So x equals 3. And over here, we're going to subtract 1 from each side. So x equals a negative 1. So now in my solutions, I would have negative 1 and 3 over here. Okay. Now, what we do there, we can actually use those as points on the graph. And we'll kind of talk about that in the next section when we graph. But if you look back over this again, all we really did, we found the axis of symmetry with this formula, negative b over 2a, which helped us find the vertex, because that was our x value. Then we plugged our x value in to the graph up here. And that gave us our y value for our vertex. Maximum or minimum, we noticed that our a value was positive, so our graph would open upwards. So this would be a minimum value. Our y-intercept is always our c value, which is negative 3. Remember, if there is no c value, then your y-intercept is 0. And then we had to factor down here to find solutions if it was possible. And it was possible. And you could factor any which way you want. Guess and check, product sum table, your square method. But once you get your solutions, eventually you'll be able to use those as extra points on the graph when we graph it. Okay? All right, let's try another one then. Number 2. Okay, so example 2, kind of going with the same thing here. We've got this equation, y equals negative 2x squared and plus 2x plus 4. So again, the axis of symmetry, remember, this is where we're going to go x equals negative b over 2a. So our negative b, remember, here's our b value. Again, I just like to write them down just so I know what they are. You can always take those. A is negative 2, B positive 2, C is 4. So our negative B over 2A is going to be the opposite of B, negative B, so negative 2 over 2 times A. So it's 2 times a negative 2. I'm really utilizing parentheses here to help us out. So now I'm going to have a negative 2 over negative 4, which then is going to reduce to a positive 1/2. So x equals 1/2 is our axis of symmetry. So if you were to kind of do a quick sketch of the graph here, okay, x equals 1/2 is your axis of symmetry. So that means, is there a point on 1/2? Yeah, sure. So here's, say this is 1, 2, 3. Your 1/2 would be here. And so your vertex would be like up here. Here's your axis of symmetry through the 1/2. Okay? And we would look at this graph and say, all right, well, the vertex is here. My y-intercept is, my vertex is going to be up here. My y-intercept's here. And I knew it opened downward because my a value is negative, which we'll get to, but that would kind of be what it would look like. All right, so we'll get to that stuff in a second. With the vertex, so our vertex, I know the first part, my x value is 1/2, all right, and now I have to plug in those values to find my y value. So I do that. I'm going to plug in the 1/2 here. And I'm not sure where. Okay, I'll do that. Let's do that over here. So I'm going to take that, go 2x squared plus 2x plus 4. So I'm going to plug in my 1/2. It's a little easier if it's like a number like 1 or 2 or something, but with 1/2, let's actually work this out. It's -2. So I'm going y equals, sorry about the y equals, -2 times 1/2 squared plus 2 times 1/2 plus 4. Okay, so that's going to keep going here. We're going to equal a -2. 1/2 squared, remember we have to square both of those. 1 squared is 1, 2 squared is 4. So 2 times 1/4. And over here I've got 2 times 1/2, which is going to be 1, and then plus 4. So now I keep going here, and I'm going to have 2 times 1/4 is actually going to be 2/4 or 1/2. So we're going to have a -1/2 there, plus 1 plus 4. And then when I keep going here, I'm going to end up, so my vertex would be, 5.5? Is that right? Oh, sorry, 4.5, because I have 5 minus 1/2 would be 4.5. So that's my y value for my vertex. So it'd be 1/2 and 4.5. And if you kind of look back at our graph, I tried to do it as good as possible here to 1, 2, 3, 4, and then this would be a little bit higher, so 4.5 would be my vertex there. What's my y-intercept? My y-intercept is 4. Remember, that's my c value. C value is always my y-intercept. That's where it crosses the y-axis here. Is it a maximum or a minimum? So because our a value is negative here, we know it opens downward, which means we would have a maximum. Maximum, because we have a vertex up top, that would be our maximum value. And then we're going to factor this as well to see if we can get the solution. I'm going to factor it over here. I'm just going to split this up and go in red. So again, taking that original equation, -2x squared plus 2x plus 4, and setting it equal to 0 to solve it. And again, if you need to pause it and factor it, go ahead and pause it. And use whatever method, square method, product sum table, guess and check. The first thing I'm going to point out, though, is that you could factor out a -2 here and then have a x squared minus x and -2. You can factor out a -2 there, equals 0. And then from there, you can bring down that -2 again, and now we can factor this trinomial. So whatever way you're going to do it, you want to pause it and do that, that's fine. But I'm just going to kind of fast forward here and go x minus 2, x plus 1 equals 0. Then when we're solving it here, we're looking at taking each factor, setting it equal to 0. -2 equals 0. Well, we know that's not true, so that can't be right. Then over here, we're going to have x minus 2 equals 0, and x plus 1 equals 0. And we know how to solve those by just adding 2 to both sides. So x equals 2, and subtracting 1 from both sides. So x equals a -1. So in solution set, our solution would be -1, comma 2. And we'll talk about how we could use those for points to graph it if we needed to. Okay? No lesson summary or practice problem today. So what we're going to do, we're just going to have this be your practice problem, number 3. So I'd like you guys to try and work on that one for today. Okay? So I know it's a long section. Thanks for sticking it out. Some other things here. Just remember, if you want to, just list your A, B's, and C's. Those help you right off the bat. And understand that this is the parent function, y equals x squared. So you'd actually have yx equals x squared plus 0x, right, plus 0. There's nothing else added there. It's the same thing as saying that. So that might help you get started on a couple of those things. And just remember, when you get down here to factor, it's x squared equals 0. So if possible, we want our solution set answer here. So give you a little help there. Hopefully that helps you. And that's it. I know it's a long section, but do the best you can. Okay, we'll see you tomorrow. Bring your questions.